All right, Tuesday in class, we learned how to use coordinate geometry in order to prove that parallelograms are parallelograms. Okay, so before I show you how to do this, one of the things that I need to do is I need to review the properties of parallelograms, because if I don't know those properties, I can't do this. All right, so the first property that we're going to talk about is we're going to talk about opposite sides being parallel. And that's what really makes a parallelogram a parallelogram. I know that AB and DC are parallel to one another, and I know that AD and BC are parallel to one another. Or at least if it's a parallelogram, they are. Okay. Another property that I know is I know that opposite sides are congruent. So that also tells me that BC and AD have the same length, as well as AB and DC have the same length. Okay? All right, another property that I know is I know that opposite angles are congruent. So that tells me that B is congruent to D, and I know that A is congruent to C. All right. I also know that same side interior angles add up to equal 180 degrees, but that's not something we're going to be working with today, so I did not put that on the list. All right, and the last thing that I want to review today is I know that the diagonals bisect each other. So I know that this right here and this right here have the exact same measure, as do this and this. Okay, so those are my properties that I have to use. The ones that I'm going to focus on today is I'm going to focus on opposite sides being parallel, opposite sides being congruent, and we're even going to talk about diagonals bisecting one another. Okay, so when I was in Algebra 1, I learned that in order to prove two lines parallel, I had to use the slope. So that's one formula that I'm going to need. Okay, and that's probably the easiest way to do it. That's probably the way I want to go with that, but we'll see that in just a second. Another formula that I could use, if I wanted to prove that two distances are congruent, so let's say I wanted to prove that the length of BC is congruent to the length of AD, okay, then I would need to use the distance formula. All right. Now, I'm going to cross out this opposite angles are congruent because that's not really going to do anything for us in coordinate geometry right now. All right, the last thing that I could do is I could prove that, because I know if it's a parallelogram, I know that the midpoint for AC and the midpoint for BD, they have to be the exact same thing, because to bisect means to hit in the middle. So I could also use my midpoint formula. Now, on your assignment that I'm about to model for you, you are only asked to do this one way. All right? Again, I would focus on the slope, and that is the way that I'm going to model for you. We will be going over the distance and the midpoint more later, but we're going to focus on the slope today. All right, let's get to this model. I've been given these 4 points up here, and I have been asked to graph them and then to say whether or not my resulting figure is a parallelogram. So the first thing I'm going to do is graph. So my first point is -8, so 1, 2, 3, 4, 5, 6, 7, 8, +1. I'm going to go ahead and graph that. That's point A. My next point is -4, +4. I'm going to go ahead and graph that. My next point is 2, 2. I'm going to go ahead and graph that. And then my last point is -2, -1. Okay, be very careful with your graphing, because if you graph wrong, the problem is wrong. All right, so considering it's me, not bad lines. All right, so here we go. So now what I need to do is I need to prove that this is a parallelogram. And I know that there are 3 ways to do this. I could use the slope formula, I could use the distance formula, or I could use the midpoint formula. Since I have a graph right here in front of me, I'm going to use the slope formula. So m is equal to my second y minus my first y over my second x minus my first x, which is also my rise or fall over run. Okay, And the reason I'm going to use that one is because it's the easiest way to do it. Because I know that in order to prove lines parallel on the coordinate plane, that they have to have the same slope. So, if I can prove that BC and AD have the same slope, and AB and DC have the same slope, then I've proven that I have a parallelogram. Okay? So, the first thing I'm going to do is I'm going to look at BC. So I'm going to draw my little triangle here. Okay, and when I count my spaces, I see that I go over 6 and down 2. Okay, so that gives me a slope of fall over run, and it's fall because I went down, and that reduces down to a negative 1/3. Okay, let's look at AD, and I see with AD that I also fall 6. I'm sorry, I fall 2 and I run 6. So that gives me a slope of negative 2 over 6, which turns into negative 1/3. Okay, so I have proven that BC is parallel to AD. And the reason I know that it's parallel is because they have a slope of negative 1/3. All right, so now what I need to do is I need to prove AB and DC. So I'm going to go ahead and draw my triangle. All right, I see that I go up 3, or I rise 3, and I run 4. So my slope here is 3 over 4. And that doesn't reduce at all, so I'm good with that. On my next one, I see that I run 4, and I rise 3. Okay, so I also have a slope of 3/4. So I can say that AB is parallel to DC, and I know that because they both have a slope of 3 over 4. So now that I have proven that opposite sides are parallel, I can definitely say that I have a parallelogram. On your assignment, not all of your shapes are parallelograms, so be careful. Some of them are and some of them aren't. Okay, as you are doing your assignment, if you have any confusion, feel free to email me or to come and see me after class, and I'll be more than happy to help you.